Hi, scientists. Miss Griffin Boyle coming to you live-ish. Same way that Mr. Vogel used to always come live to Falcon Focus, right? Live. I'm here to talk about your anchor project. I've gotten a few emails. Miss Sackett has gotten a few emails. And these were things that we would have gone over had we been in school in April, and we all know that's not happening. So we made a video take you through the first few steps. We're going to have a Google form for you to complete at the end of the week after you have done these steps. And then week 2, we'll go over some more. So you're going to get these in short little chunks because that is more manageable with everything that's going on this week. So let me switch over to my document camera and take you through your packet. So if you don't have your packet with you, I would pause this, go get your packet, and then press play. If you are doing most of this online through Google Classroom, again, if you don't have that tab open, you should pause this, get that tab open, and then press play. Okay, so remember, we have essential questions that at the end of all of this, you are going to need to answer these essential questions. So right now, I know that all of my kiddos, and I believe all Cobalters, have picked their scenario and gotten it approved by Miss Sackett or myself. If you have not yet done that, if you don't have a little GB or a Sackett or however Miss Sackett said that she knows what your scenario is, you need to email us your scenario. So we have our rubric. This is going to be very important to follow, more so now than ever, okay? This is your 4th anchor project. You know that we follow this rubric and that this is important and these are summative points. So again, you can't be putting this off till last minute. One quick note, the engineering fair poster board we have said could be digitally done through a slideshow or with actual poster board. That's still the case, provided we go back to school in May. If something were to happen and we follow the other states who are just digitally learning till the end of the year, it then obviously will have to be via a slideshow. So we did our gravity clocks, that was kind of cool, and now we are here. So for this page, scenario copied from the handout. So that was the scenario copied from back here. My kiddos, I signed this. I put a very sloppy GB on this. And I believe I got all of you. If I haven't, we'll put that in the Google form. So the Google form first thing is going to ask you what your scenario is. You just type in exactly what your scenario is. Then our problem statement, we had said in Foxes that we took this cutesy little science or cutesy little story about finding foxes, helping them get across the river, and we put it into a problem statement that started with I need to. And it might be I need to build, probably. I need to create, I need to make. But take this scenario and what do you actually need to do? So we had a cute scenario about foxes having to get across the river, and we turned that into I need to build a boat that can hold the most mass. So we're taking the cutesy out of this and breaking it down into its actual science. What do you need to do? We're going to ask you this on our Google form as well. The next thing on our Google form is going to be research. We have part 1, we have part 2 for research. What do you know about the problem? So this, of course, should start with I know, I know, I know. You need to have at least 3 of them. You can definitely have more. The more you know about your problem, the better off you are, but you have to have at least 3. With foxes, we could not say, I know this is hard. I know that foxes live in the forest. We had to go back to our supplies and our materials and our purpose. If we were trying to hold the most mass, we wanted to figure out about boats and our supplies holding the most mass. I know wood floats, popsicle sticks. I know it can't have holes. I know that coffee filters absorb water, which is a bad thing. These were examples of the I know statements as they related to our problem statement for foxes. So you are going to look at your problem statement and think about supplies you might get, think about what you actually need to do, And on our Google form, write in 3 I knows after you've worked them out and written them on this sheet of paper or typed them in on this document online. What questions do you have about the problem? So these are questions. Again, you need to have at least 3. 1, 2, 3. Questions are going to start with how do I? What is better, blank or blank? Why does this material work so well? If you can answer that, where is the best spot for on your design? Okay, at least 3. 3 things that you could answer by the time you are completed with this project. We are going to ask you this as well on that Google form. The next step would be design. We have you draw and label. Okay, this is important. This box might not be big enough. You may want to do this on notebook paper so that it's spread out and you can really actually read it. This label is the part where kids typically get things off. Remember with foxes, we had you be very, very specific with your drawings and very, very specific with your labels. Anything you put on here, you have to put in your first build. Anything you don't put on here, you cannot put in your first build. So this is an incredibly important step because some of you, as you found out with foxes, you start to build and you realize it's not going to work and you want to change it right away and you can't do that. Or some of you start to build and say, ooh, I really wish I had put this in there, and you can't do that. You're also going to list every material that you need, including things like tape, okay? On our Google form, we are not going to ask you to show us these. We are going to ask you to describe what you are thinking with these, knowing that this and this are going to be either on that final poster board or that final slideshow. So as you are doing these, your scenario is an easy type on a poster board, type on a slideshow. Same thing with problem research for both the I knows and the questions. Your drawing and your label could also be easily put on a poster board, tape it up. It could be taken a picture of and put it in your slideshow. So our week 1 form is going to be about these 3 steps. Some of you might be beyond that, and that's okay. We're going to go over in our week 2 video how to do the last few steps and what that means. One thing I caution you on very strongly is if you are past the design step, if you are all the way past step 3, you are already building and testing, you are already perhaps even redesigning. Every step along the way, take a picture of what you're doing, because in your slideshow, you are going to want to put those in so that we can see your steps. If Miss Sackett and I can't see your steps, we can't give you credit for it. And on your rubric, it specifically says that your poster board includes all of our steps. So any redesign and test you have to show, okay? So you need to make sure that you are taking pictures of all of your steps as you go. It's better to have too many pictures than not enough pictures, okay? As always, feel free to email us or Google chat us during our office hours that we went over in our expectation videos, or Fridays from 9 to 11 in your Hub Science calendar. Click on that Google Hangout link and you can ask us live in person. All right, happy engineering design cycle!